A movie theater charges $8 for adults, $4.50 for children, and $6 for senior citizens. One day the theater sold 405 tickets and collected $2,320 in receipts. Twice as many children's tickets were sold as adult tickets. How many adults, children, and senior citizens went to the theater? So in this problem, they're asking us to find three different things, three different values. So we can represent each of those things, the number of adults, the number of children, and the number of senior citizens, with a distinct variable. So I'm going to say that X is the number of adults attending this theater, and Y is going to be the number of children and Z will be the number of senior citizens. So we have three different variables we need to find, so we need to make a system of three equations in these three variables in order to solve the system. So let's look at the information we're given. It's telling us that the theater sold 405 tickets total. So if I add the number of adults, children, and senior citizens that attended the theater that day, I should get 405. So I can make my first equation, X plus Y plus Z equals 405. So I'm adding number of adults, number of children, and number of senior citizens to total the total number of tickets, 405. Now let's look at a money equation. So this equation that we just did is purely number of people. Let's make another equation now that uses the money. So we know that each adult ticket costs $8. So I can say 8 times X would be the value of the adult tickets. And then each child's ticket cost $4.50. So the value of those would be 4.5 Y. And then each senior citizen ticket is worth $6, so the value of the senior citizen tickets would be 6 times Z. So if I add the value of all those of the adult, children, and senior citizen tickets, it should give me the total amount in receipts, which is the $2,320. So I've got two equations now. I need one more, and if I look at the last piece of information I'm given, it says that twice as many children's tickets were sold as adult tickets. So twice as many, 2 times. So I can say that Y, my number of children, number of child tickets, is going to equal 2 times X, 2 times the number of adult tickets. So now I have three equations with three different variables. Now notice the third equation doesn't contain the Z, but that's good. That actually makes our system a little simpler to solve. So remember, the method that we have to solve systems of three equations and three variables is elimination. So I'm going to rewrite this third equation here. I'm going to subtract the 2x from both sides so I can get this into the standard form here like the first two. So I'll have negative 2x plus y equals 0. So now, in my third equation, the z has already been eliminated. There is no z. So to use elimination, all I need to do is pair up my first two equations and eliminate z, and then I can make a system of two equations with two variables. So I'm going to rewrite my first two equations. X plus y plus z equals 405, and 8x plus 4.5y plus 6z equals 2,320. So now, in order to eliminate the z's, I've got to get a negative 6 here as the coefficient because I've got a positive 6 here. So I'm going to multiply my first equation by negative 6. So if I multiply everything by negative 6, I'll get negative 6x minus 6y minus 6z equals 405 times negative 6, which is 2,430. So I'll rewrite the second equation, 8x plus 4.5y plus 6z equals 2,320. So now if I add down the columns, I've got negative 6x plus 8x, which will give me 2x. I've got 6y, negative 6y, and 4.5y, so if I add those, I'll get negative 1.5y. And now here, like we wanted to happen, the negative 6z and positive 6z will add up to 0, so we've eliminated the z's. And then if I add my constants, oh, and this should have been a negative here. When we did 405 times negative 6, this should be a negative 2,430. So when we add down this column, negative 2,430 plus 2,320, we'll get negative 110. So now we've got this equation in two variables, and if we pair that with this original equation, negative 2x plus y equals 0, which is also in two variables, we can find x and y. So I'll rewrite those. I'll rewrite that original negative 2x plus y equals 0, and then the one we just found here, the 2x minus 1.5y equals negative 110. So now, this is actually set up very nicely to eliminate the x's just as it's written. So we don't have to do anything. We just add down the columns. The x's are eliminated. And then we need to combine y and negative 1.5y. So we're going to get negative 0.5y. And then we add our 0 and our negative 110. And we get negative 110. And then if we divide both sides by negative 0.5, we get y equals 220. So remember, our y represents the number of children that attended, the number of child tickets. So 220 children attended. So now we can substitute this y back into either of these equations in the two variables in order to find x. So I'll substitute into the first one here because there's no coefficient on the y, it's just a 1. So I have negative 2x plus 220 for my y equals 0. So if I add the 2x over, I get 220 equals 2x, and divide both sides by 2, and I get 110. So x, we defined it, represents the number of adults that attended, or the number of adult tickets, so 110 adults. And then finally, to find the number of senior citizens, that variable z, we can take these x's and y's, the x and the y, and substitute back into either of these original equations that contain the z, and we can solve. So I'll use the first one because, again, there's no coefficient on the z, it's just a 1. So I'll substitute in a 110 for x and a 220 for y, plus z equals 405. So if I add my 110 and my 220, I get 330. And subtract the 330 from both sides, and I get z equals 75. So z represents the number of senior citizens, so 75 senior citizens. So don't forget, in any word problem, but especially these where you're finding multiple quantities, make sure you define the variables. Make sure you don't just use x, y, z. Make sure you define what x, y, and z actually represent.